Now we're ready for chapter 16. This will be the last chapter we cover, a required chapter. I think there's another chapter in the book that you can do as your final project. It's one option. And then we're going to learn to take multiple parts and put them together into an assembly. This is the real power of solid modeling. And then we can define how those parts relate to one another. And we can even do things about model. We can even constrain them so that they're allowed to move certain ways relative to other parts. And we can show how a whole machine would work. So that's what we're not going to go that far, but we're going to learn how to do a basic assembly. Assembly model shows how they relate. Good practice. There's several good practices. There's multiple ways to do it. You assemble the parts based on how you would want them actually assembled if I were doing it by hand. If it's complicated, you can break it down into sub-assemblies and then put the sub-assemblies together. A sub-assembly and an assembly as far as AutoCAD is really basically the same thing. Inventor lets us define how parts are put together. We call those constraints. These are assembly constraints, and the technique he uses he calls directive additive assembly. Sort of three ways, he defines three ways to do an approach. You got the bottom up, whereas what we're doing, you're going to draw each part individually and then put them together. The other one is kind of a top down, where you sort of design the whole thing and then you break it up into parts. And then there's the middle out approach, which is a combination of the two, which is probably how most people actually work. You have you know something about the part and you draw individual pieces, and then you go into an assembly and you start putting those pieces together, and then you create new pieces as you see what you need. So this is what we're going to do in this chapter. There's 1, 2, 3, 4 parts here. You don't have to draw the screw twice. You'll be able to include a given part as many times as you need it. There may be another block. I'll have to look and see if he still does that. He used to add just a little block to put it on, so there could be 5 parts. Now, all he does is give you the picture and say, draw this. Here's what I did if you want a little direction. Draw your collar, use the XY as your base plane, and then you can rotate about the X-axis. The bearing, start the base in the XZ plane and make sure your holes line up along the X-axis. The base plate, base in the XY plane, the longest part of the base plate's along the X-axis. The screw, I actually drew. I had a little trouble with it, so I drew it in AutoCAD. I used a 3-point circle to do that, and then brought it in as a sketch and rotated it. And then there's a thread command you can add to the screw. And then you'll have to start an assembly, which is a separate type of file, and you'll add each one of the parts one at a time, and then you'll constrain them and how they move relative to each other. So the base part needs to be the base part, the things you're going to add things to. So that's the base, and then he's going to add another part, and basically you're going to fix the base to the origin if you follow his instructions, and then you're going to add this part, and the way I did it, I ended up having to rotate it. If you right click, you can rotate it around different axes to make it look like his picture. So you can do that. But then when we go to do the assembly constraints, we need to think, and this really comes out of mechanics. If you think about an object and how it can move. It can translate, so it can move along the x-axis, it can move along the y-axis, it can move along the z-axis. Those are called degrees of freedom. So it has 3 translational degrees of freedom. But then it could also rotate, and I should say any other translation is some combination of those. And it could also rotate about each one of those axes. So it could rotate around the x-axis or around the y-axis or around the z-axis. And rotation around any other axis can be resolved into rotations about those 3. That's something we'll talk about if you take statics, for example, certainly in dynamics. So any object has essentially 6 degrees of freedom if it's free to move in any way. 3 translational, 3 rotational. And that's the way AutoCAD talks about it, Inventor talks about it and deals with it. And what it lets us do is he shows you how to see which ones are free, and then as we add the parts together, we constrain different ones of those degrees of freedom. All right, once you've got parts in, then you're going to do your assembly constraint there are several. It's going to limit the degrees of freedom. In AutoCAD, there's 4 types. We'll talk a little bit more about all the types, but at least on this, there's 4 types. And that constrains how it's going to move. And then you can still grab the object and try to move it. And if it's constrained, for example, to line up the 2 holes, then you can rotate it around that hole. And you need to play with these things to see how they move. Exploded assemblies are often used to design presentations, catalogs, sales literature, or when you buy, say, a shelf or a desk, and it came in a car, you got to put it together. Then that's what you'll have, is these type of exploded views with instructions on how to assemble the thing. He creates assemblies a couple of different ways. He talks about it. We're going to use what's called the assembly modeler, and where you can move things around. And here he also, that's what he's going to add this other block and show you how to do constrain things a little bit differently. Remember, the different types of assembly constraints are mate, where you're just putting 2 things together. Flush, you're still putting 2 things together but side by side, an angle between them, 2 solid objects that are tangent to each other. You're going to insert a screw in a hole, and then you can make use of symmetry. Make sure you look all of those up, and he talks about each one of those in the book. Then we're going to create, once we have our assembly, we're going to create a parts list. He'll show you how to do that. That's on a drawing. So just follow his instructions, and you'll have a drawing file too. And in that drawing file, you'll list the parts, and you'll use balloons to show which part. So number 5 is your A block. And we'll set the materials. And I want your materials set on your parts, as he's indicated. And then you'll have this. So when you're all said and done, I should say 5. There should be 5 part files. There should be an assembly file, and there should be a parts list. So there's no quiz or no end of chapter problem. This is basically your last assignment. And then we'll have a final project that you'll do, which for many of you will be to do another assembly. I'll put up more details about that later. If you have any questions, shoot me an email.